Welcome back guys to Mech Digest by Komal. With reference to my last video where I have shown you the modeling of all the parts in Radial engine, today we are going to see the assembly of the same. Here we see that in this drawing, this assembly is made up of 4 sub-assemblies of articulated rod assembled in the main assembly of master rod. So let us see how it goes. The first part is master rod, which is going to be assembled at the origin of assembly in order to be fixed. The second part is going to be rod push upper. Let me tell you how did we decide the second part is going to be the rod push upper. For that we have to check the drawing of master rod where we see that this ID is 24 and the rod push upper has the OD of 24. So let us mate it, concentricity, and log the rotation. Then assembling the top planes in order to fit right in the place. Next part is master rod bearing. Its OD is 52 and in master rod we see that here ID is 52. Concentric, lock rotation, okay. Now the next part here is going to be piston pin. Again it is going to be concentric with rotation locked. Taking the top plane of piston pin with top plane of master rod. The next part and the main part, which is piston, will be assembled here at the piston pin. So concentric, and this time we won't be locking the rotation because the orientation of the piston has to be changed. So we will use coincident to coincide front plane of master rod to right plane of piston, and front plane of piston to top plane of master rod. Then here we are going to use piston pin plug. Mating the cylindrical faces, lock rotation, and now mating the faces. Done. Now the same part will be mirrored on the other side as well. So let's use piston pin plug and mirror the same with respect to the top plane of the assembly. Okay, so we have the same component here with the same constraints. Okay, now let us call piston ring. Okay, again mating the faces, lock rotation, match these faces in order to fit the piston ring in the grooves of the piston. Now the same piston ring we want it for the other three locations, so we won't repeat the assembly. We are just going to use linear component pattern in order to have the same piston ring in the grooves. So select piston ring from design tree, provide the direction. Okay. Including the parent object, we have to use 4 numbers. Okay, let's change the direction. And the gap is going to be 5. Okay, let me tell you how this 5 was calculated. We see that the groove gap is 3 and plus 2 for this part. So that makes it 5. So guys, we are done with the main assembly of radial engine. Okay. Now the next we are going to do is using the sub-assembly to assemble at these 4 locations. So let me call the sub-assembly. Okay. Now this is the sub-assembly of articulated rod, where in this area we have used rod bush lower, and for this area the same set of parts are used as of master rod. So we just need to fit them at these 4 holes. In the drawing we see that they are all assembled at a particular angle. So let us calculate the angle and I'll show you the shortcut how to calculate the angle. Okay, so for that we need to have master rod opened in the separate window. Okay. Now just for the reference purpose, I am going to create the center line. Okay. Now let us check the angles. This is 70.77 and the next is 76.21. You just have to remember these angles and please discard these changes. Okay. So it's simple now. Let us use mate. The first constraint is going to be the same, mating the cylindrical faces. And here we do not have to use lock rotation because we have to give it a particular angle. Okay. Let us again use coincident to coincide the top planes of both the assemblies. And now, using the angle constraint, let's take front plane of both and angle 70.77. Okay. We are again going to call the same sub-assembly and giving the same set of constraints with the different angle. Drag it to position it, angle constraint, (76.21). The next part to be assembled here is link pin. So let us call link pin. Okay. Coincide the cylindrical faces, lock rotation, and mate these planar faces. Same for this location as well. Concentric, lock rotation, and mating the planar faces. Now let us use mirror for these two sub-assemblies and link pin to be assembled on the other side. So let us select them from design tree and define the mirror plane as front plane of master rod. Here we are done with the assembly. I hope guys you find my techniques easy to understand. I would really welcome doubts or questions from you in my comment box that I will surely solve. And for us to stay connected, you need to subscribe to my channel. Thank you guys.